Hello everyone, welcome to class. Thank you for being so understanding and for those of you that left those nice messages. I do really appreciate it. He's doing just fine. He just had a high fever and he showed us with some spots this morning, so we just want to make sure that he was all okay. But all is good, so I appreciate that. Today we're looking at week 2, day 2, and we will have mystery numbers today. Um, so we will go over in class tomorrow exactly how to access them through the Dropbox, but know that you will hear mystery numbers, and that's kind of my way of keeping attendance. Instead of doing an extra assignment or making you do more work, I know we have book work, and we have Class Connect, and then we have quizzes online and whatnot, that it just gets to be too much. So just listen for mystery numbers, write them down, and then you can submit them to the Dropbox. If you know how to do that, today we're looking at week 2, and today is February 3rd. So you can always look in the Dropbox um, for those assignments. Okay, so yesterday we talked about our new words, which were infer and evaluate. And infer, we talked about where you're kind of like a detective, right? You're using the clues that are given in that problem in order to make a deeper understanding of something. If we're looking at this inference party to the right, you can see that there are 2 questions there. So it says Natalie is pouring eggs, flour, sugar, butter in a large bowl. She then mixes it with a large wooden spoon. She prepares the batter to be placed in the oven. Where is Natalie? A, the bedroom, B, the bathroom, C, the dining room, or D, the kitchen. So it's not told explicitly what is given there, but we can make enough of a conclusion, we can make an inference, knowing what we know, to say, well, she has to be in the kitchen. She's using ingredients. She's probably making a cake or cookies. And there's an oven there as well. So we know we can make that conclusion. And that's kind of what an inference is. You will see this in math word problems as well, is that we have to take what we're given in order to make an understanding of it. To evaluate, we can look at that and we can say, okay, well, evaluate means to solve. So if we have to evaluate 2x plus 6 when x equals 5, we'd take this 5 and substitute it in for the x. So I'd have 2 times 5, which is 10. 10 plus 6 equals 16. And that would be how we evaluate in math. Today we're going to be looking at lesson 1.06, which is function equations. So we're going to look at how to, this is the second half. Yesterday we talked about what function notation looks like. And today we're going to look at how to input those values, which is nothing and honestly new. It just is going to look a little bit different than what we've seen because we're using it in function notation. So I want you to think back just for a second here. How did I know if something was in function notation? Well, in order for it to be function notation, we had this f of x. And so it would be called the function of x. Now, your function notation can actually be replaced quite easily with a g of x. Or you could have an f of d. It just kind of depends on what the variable on the second half of the equation is. Yesterday we were looking at all lines, and in lines we had an x and a y, and that was why we used the f of x specifically. But when we're just using them to evaluate expressions, you will see that there are other options available as well. So I want you to think about a machine when we have a function. And the function machine helps us out, because what it says here is that we have an input and we have an output. So we're going to put some value of x in, and we're going to get an f of x out. So let's say my rule was to times by 2 and then add 3. So we have 2 operations going on. So if I put a 6 in, first I'm going to times it by 2, so 6 times 2 is 12, and then I'm going to add that 3, so my output becomes 15. And that's what we're going to be looking at, is how can we take a number, put it through some sort of machine, or in our mind, a rule with some math, do some math to it, and then we're going to get a new output. Typically when you see this, you will see that there are input-output tables. And you will see, so if we're looking at number 9, we have f of x. So what you will see is x and f of x. And we've seen this before as x and y, but now we're in function notation, so we have to make sure that we're looking for the correct variable. Then I have 3x plus 4. So my first value that I'm going to substitute in for x is going to be 1. My second value is going to be negative 5. So in my equation, I have 3 times 1 plus 4. 3 times 1 is 3 plus 4 is 7. So when f equals 1, f of x equals 7. We can do the same thing for the negative 5. So I do 3 times negative 5. It gives me negative 15. Negative 15 plus 4 gives me negative 11. So when x is negative 5, f of x would be negative 11. Now you can see as we're looking at this here, we have a t of x, we have a g of x, we have an f of an a p of an x, and a c of an m. They all operate the exact same way. We're just looking at different variables now, and that is completely okay. So we're going to erase our board here. And we're going to do another example. Because these equations are not being specifically related to a line, we can change out the variables. So let's do number 13 here. We're going to do p of x. So I have x, and then I have p of x. So x is going to equal 2 and 0, and I'm getting those values from a and b. And my equation is 6x minus 15. So when x is 2, I'm going to substitute that 2 in for x. So I have 6 times 2 minus 15. So I have 12 minus 15, and I get negative 3. So when x is 2, p of x is going to be negative 3. So again, you've seen this evaluation of these variables, right? This is what it means to evaluate. We're substituting these values in to get an answer. But now we're looking at it in specific function notation. So now I have 0, so I can do 6 times 0 minus 15. 6 times 0 is 0 minus 15, and I get negative 15. So again, it's just working with what that variable is. Okay, so let's look at it though when we actually have a word problem and we have a graph that goes with it. So it says when a spring is extended from its natural state, the spring exerts a force. So we're talking about like a spring, not like the weather, not like the season, but like a spring you're going to find in your clicky pen or your clicky pencil, right? Little metal piece where you coil it all up and you can squeeze it in your fingers and it kind of springs back at you. Okay, so we're connecting some science here. So it says the graph below shows Hooke's law for a specific spring, or how this force is dependent on the extension in the spring. So now we're going to look at this and we're going to analyze, right? That's kind of what we talked about last week. Let's break this down. Let's really evaluate what this is talking about. So it says, what force does the spring exert when it is extended 6 centimeters from its natural state? So now we want to find what our f of x is when our x equals 6. I could find the equation of this line, just like we looked at yesterday, and I could substitute it. Or I could say, okay, well, if I'm at 6 centimeters, let's see where it crosses my graph. And let's go over this way. And you can see that it's at 3. So the force then would be 3 newtons. Newtons is how we get the measurement of force. All right, how much more force does the spring exert when it's 9 centimeters than when it's 7? So now we have to figure out the difference between 9 and 7. So we're going to analyze this here. We're going to break apart our little steps, and we're going to first figure out what it is at 9. So at 9, it's 4.5. And at 7, we're at 3.5. So my difference would be 1 Newton. So again, yesterday we learned how to use those graphs to find that equation of the line and then put it in function notation. And we could do that also. We could see where does it cross your y-axis. It crosses at 0. What's my slope? Or you can just connect those points to find out your x and your f of x coordinate. Either way will work. Okay, so we need some mystery numbers. How about our first mystery number is 6. Our first mystery number will be 6. So your job today is to complete 1.06. Again, I apologize for missing class today. Submit your mystery numbers or keep track of them if you want to submit them later this week. So our second one will be -10. Normally I will not write them down. This is just for today. I can't type them into the chat and can't say them a few times just because our video is a little bit shorter. So typically I won't write them down. You will have to keep track of them. And I will see you all tomorrow. And again, I appreciate you understanding my circumstances earlier this afternoon. So have a fantastic day. And I do have office hours tomorrow from 1 to 2 p.m. if you want some extra help. Otherwise, I will see you all in class. Take care.